Hi everyone, welcome to my session at the ANU Hackathon. My name is Eldar Rubinov. I am a positioning geodesy technical lead at Frontiersi, and today my presentation is going to be on a 5G positioning testbed. So this is a project that we're about to embark on, and I'm going to tell you a little bit about it. So the presentation is 5 minutes only, so I'm going to keep it very high level. And to start with, I'm going to start talking about precise positioning in general. So until very recently, precise positioning, and by precise I mean centimeter level positioning, was always a domain of professional users in a number of industries, including surveying, including agriculture, construction, and so on. But as you can see, these professional users would also use very professional equipment that would cost thousands of dollars, that would be bulky, that would require big antennas, would require some interface devices, some hardware and some software, and so on. And even though the most important part of that puzzle to achieve the centimeter level positioning is getting some differential correction from a known source, because by itself, even the most expensive GNSS receiver would not be able to get that level of accuracy. And the correction can be different types of correction. They can be delivered in a different ways, via satellite, via internet, via UHF radio, and so on. But what I'm trying to get at is that this sort of application and this sort of equipment was never meant to be carried in a pocket by an average everyday user. However, that is beginning to change, and it's beginning to change very rapidly. And there are a number of factors that contribute to that change. First of all, there are a lot more navigation satellites out there. These satellites have a lot more different signals, which can be exploited by the receivers. The receivers themselves are becoming much smaller, the chipsets. They're becoming much more powerful. They're becoming much cheaper. So instead of costing thousands of dollars, they now cost hundreds or tens of dollars, and they're small enough to be put in mobile phones. So this led to the industry taking far beyond what it was originally, and that it has always been. So now potentially everyone with a mobile phone or with a drone or with an autonomous car in a few years' time is going to be a recipient of precise GNSS corrections. That obviously brings a number of challenges with it, and one of those challenges is delivering the corrections to the mass market. Again, until recently, the corrections only targeted a very small number of users. We're talking potentially 1% of the population. And once we scale it up, then those old ways of delivering the corrections are not going to work anymore. And this is where we have to explore new ways of delivering the corrections, and this is where 5G comes in. So what we're going to do is we're going to try to use 5G as a new method of delivering the corrections. So in the telecommunication industry, they have now a set of standards called Third Generation Partnership Project, or 3GPP, which is essentially an umbrella of various standards. And in one of the latest releases of that standard, they have now made provisions for GNSS corrections, and specifically what's called state space representation, or SSR corrections. So that means that we have the capability of actually transmitting these corrections to just about any device, including a mobile phone. And this is what we're going to try to test in this project. So in theory, it's doable, but it hasn't really been done yet. There are a couple of companies in the world that are doing this, or starting to do it, or doing it at some level, but it's not a widely used technology yet. And again, this is what we're going to try to do. So for our test bed, we're going to use Optus, we're going to use Ericsson, and we're going to use another Spanish company called GMB, and we're going to set up the required infrastructure in order to achieve this. So we're going to take those, we're going to make the SSR corrections, and instead of transmitting it in a standard sort of way, we're going to now encode it in this 3GPP standard, and then we're going to disseminate it to the users via the Optus towers. So the first part of the project is we're actually going to set up the required infrastructure. And then the last part is we're going to run a number of projects. So that is essentially it. That's a very, as I said, very high level explanation of what we're going to do. If anyone has any interest, this is my email address, and feel free to get in touch with me anytime. Thanks very much.